Hi everybody, I'm Emily.
And I'm Maggie.
And we're from Salem Sound Coastwatch, a marine science and environmental education organization right here in Salem. And normally we do this program with you in person in the schools. But of course this year we're going to do a video with you. We're going to explore this model.
So this model is not just a bin full of sand and felt. We're going to imagine that this is actually a watershed and that these little pieces of plastic are actually sand or soil and the different things that make up our watershed. And a watershed is any area of land where all of the water within that area drains to the same major body of water. In this case, any water that falls up here on the land part of our watershed flows downhill into this major body of water.
Just like here in Salem and in the Salem Sound watershed, if we pretend that this is Salem Sound, then all of the land up from Salem Sound, like Salem, Beverly, Marblehead, Manchester, Peabody, and Danvers, all of that water flows from that land and those towns right down to the ocean.
Before we get started in our model, we're going to get our science minds turned on and get our investigative juices flowing. So what observations can you make just by looking closely at this tube?
And remember, an observation is using your eyes and your ears and your mind and your nose and whatever other sense that you have that you can get information with.
And then we'll make observations about our watershed.
What if you shake it, Maggie?
Do you see anything moving in these tubes? Do you hear anything moving, anything rubbing together? Does this tube now look different than this tube? What about this one? Do you notice the smaller pieces staying at the top and the biggest ones at the bottom? Why do you think that is?
So let's take our observations we made in the subtle tubes and connect it to what's going on here in the stream table. So we've got sediment or bits of rocks. In this case, it's plastic, right? It's not real rocks. In nature, what would happen is these rocks would bang together and make sand, like at the beach, or little bits of rocks, little pebbles. So we've got our stream flowing here, going downhill and eroding, right? So we've got the water carrying, or sometimes it would be wind or ice. In this case, we have water carrying the sediment down the stream. And then what happens to it? It stops. You can see it build up right here, like building a beach. And that's called deposition. So the sediment is deposited downstream.
Those natural processes like erosion and deposition are happening all the time, all over our land and in our watershed. And why do we care? Well, what if one of our houses was right there on the riverbank or on the shore like we have here in Salem? Those processes could affect our lives and our homes. So what are we going to do about it? So there's some things missing right now in our watershed model. If you were to walk on the beach, even on the calmest day, what would you see there that you're not seeing in our model? Is the water always crystal clear and still? No. Water at the beach is moving at all times. The tides are coming in and out, and there's always some wave action, even when it's not a storm. So Emily's going to add some waves to our model here.
I'll use our wave generator. Some nice, slow, gentle.
What are we seeing happen to the land that's holding that house above the water?
Uh-oh. And what if there's a storm?
Those waves are going to get bigger, the wind is going to be stronger.
Oh no, that's a big problem. Hey Maggie, I really like living on the shore. It's a beautiful view of the ocean. I can't just pick my house up and move it back, right?
Way too expensive.
way too expensive.
So what can we do to work with the land to protect our houses and the shore from erosion? So you guys at home or in your classroom are going to become the engineers to solve this coastal erosion problem. You're going to use the materials that you have in front of you, or maybe some that you found outside, to stop erosion on the coast. Plants, like in salt marshes or sand dunes, not only prevent erosion, but make a great habitat for lots of different animals. These could be tall plants with short roots, or maybe short plants with long roots. Rocks. Anytime you go to the beach, you see rocks of all different shapes and sizes. Some of them were already there, and some of them were put there, like coastal engineers trying to prevent erosion. We brought 2 different seawalls. Seawalls can be made out of cement, bricks, rocks, any hard material. So get creative with whatever you can find.
Now it's your turn to go build your solution to coastal erosion. Maggie and I will work on ours and we'll check back later. So Maggie and I have completed our design. We have a salt marsh here and over here. We have sand dune grasses up here. We even put a living shoreline in here with a coral log and plants coming out of it. We've got 2 seawalls, one here and one here. And we've raised up our buildings. Do you notice they're on stilts and platforms?
One thing I like about our design, and I hope that yours looks a little bit similar, is that we didn't rely on just one solution. We knew that just a seawall might not be enough to protect those houses. We knew that just a bunch of rocks wouldn't have been enough. So we put many design elements together to create this solution and beautiful shoreline.
So should we see if it works?
Sure.
All right, here come the waves. Gentle at first, right? Every day the tide comes in and the tide goes out. The wind is making some waves. It's faring pretty well. But what if we get a big storm? How will our design hold up? Look how well the salt marsh grass is absorbing the energy of the waves. There's still some movement of the sand, but for the most part, we're doing pretty well. Here comes a big storm. And sometimes we get nor'easters, big storms, or hurricanes in the fall. Oh boy, we're going to have to repair our seawall. So engineers, they redesign all of the time, getting things just right. And I'm noticing this side over here didn't move quite as much. So what if we rebuild this seawall and we put a rock in front of it and our marsh grasses?
Because we can't stop these waves from happening. We can't stop storms from happening. We can't always stop the land from changing. So we have to adapt and redesign and rebuild some of our solutions. Just because they don't work perfectly the first time doesn't mean they can't work. Nice, Emily.
Wow, this was super cool, Maggie. We built some really good solutions here.
We did.
I bet you made some cool solutions at home too. When you're out and about in your community next time, you'll probably see some of these solutions that we did here and that you did at home, like a seawall or riprap or a living shoreline, like Collins Cove in Salem. Scientists are always observing. You might make some observations out there as a scientist too.
And maybe you'll come up with some new ideas that you didn't have a chance to build today, but it's gotten your engineering minds working. Well, thanks for building with us, engineers. We hope you learned a couple things. We hope you had fun exploring erosion right on your kitchen table or in your classroom, and we look forward to hearing what you came up with. See you next time.